Hello everyone. Today we'll do the expression for capacitance on introduction of a metal slab. We can call it a metal slab or a conducting slab. So we did like we did in the previous derivation, we'll consider a capacitance, a capacitor of plate area A and separation D. I'm not going to write the same considerations again. Plate area is A and the distance between the plates is D. We'll also consider that E naught is the electric field between the plates. We'll insert a metal slab of thickness T. So introducing a metal slab. The thickness is T. Now E is the electric field inside the plate, but let it be EP. So electric field inside the metal slab will be E is equals to E naught minus EP, which is equal to 0. Because the electric field inside a conducting slab is equal to 0, which means E naught is equals to EP. Now V is equals to E naught D minus T plus 0 into T. Due to this, so we get E naught D minus T. E naught can be written as sigma epsilon naught D minus T Q by A epsilon naught D minus T, as we did in the previous derivation. We now will take V there, so we get Q by V is equals to AE naught D minus T, and this is capacitance, so we get C is equals to AE naught D minus T when we introduce a metal slab. Also, like we did in the previous derivation, we got C is equals to EA naught upon D minus T plus K when we insert a dielectric slab. As we know, K is equal to 0 for metals. So, we get C is equals to AE naught upon D minus T from here also.